All right, it looks like we are live and streaming. And so good morning, folks, and welcome to the special meeting of the Climate Initiatives Task Force. It is 9:06 a.m. on October 19th, and I'd like to call this meeting to order. Ms. Kinchin, would you please call the roll?
Chairman Vorhoff,
Here.
Mr. Moses,
Here.
Mr. Hawes, Mr. Lambert,
Here.
Mr. Lankflos,
Here.
Mr. Myers,
Here.
Mr. Bro,
Here.
Mr. Calavoda, Ms. Bush,
Here.
Mr. Hardy,
Here.
Mr. Robertson,
Here.
Mr. Gray,
Here.
Mr. Bowser, Mr. Berg,
Here.
Dr. Burkett, Ms. Gotro, Mr. Daniels,
Here.
Mr. Chambers, Mr. Schwartz, Ms. Pishon Battle,
Here.
Chief Dardar, Mr. Verchick,
Here.
Ms. Manning Broom.
Here.
You have a quorum.
All right, thank you. And I'd also like to let the record reflect that Mr. Haas is present, and Ms. Tokisha Collins Wright will be serving for Mr. Bowser. So today we will be focusing on carbon capture and storage, known as CCS, and sometimes referred to as CCUS, with the U standing for utilization. 10 days ago, we met and did a deep dive on industrial decarbonization. We learned about the 4 pillars of industrial decarbonization: energy efficiency, electrification, fuel switching to low or no carbon fuels like hydrogen, and CCUS. We also learned how they can all play an important role in decarbonizing the industrial sector, and that we can't put all our eggs in one basket. Recognizing the context that we gained in our last meeting, today we'll be doing a deep dive on CCUS, learning what it is and identifying and discussing opportunities and challenges. I also want to make sure everyone is aware of recent announcements relative to CCUS in Louisiana. Industrial gas manufacturer Air Products announced last week a $4.5 billion blue hydrogen and blue ammonia facility in Ascension Parish, with a target of sequestering 95% of its CO2 emissions. It's called blue hydrogen ammonia because it'll be using natural gas as a feedstock and then sequestering the CO2 that is a byproduct of making hydrogen. At more than 5 million metric tons of CO2 sequestered each year, this would be the largest CCS project in the world. As Governor Edwards stated last week, these kinds of projects can further Louisiana's efforts to reduce carbon dioxide emissions while maintaining jobs and growing our manufacturing base. He recognized that this project is a clear demonstration of our ability to grow the Louisiana economy while lowering the carbon footprint of industry. Earlier this month, the State Mineral Board issued 2 operating agreements as well, one to Air Products and another to a company called Capio, to sequester CO2 under certain state-owned lands, including Maurepas Swamp, or parts of it, parts of Lake Maurepas and Sabine Lake. I want to emphasize that Governor Edwards also stated last week that we will make absolutely sure that the geologic formations are proper before this moves forward. So while these projects are being announced and developed, there is still a thorough permitting process that needs to take place. There's also an important role for this task force to make recommendations that make these processes and programs better, more protective of the environment, communities, and public safety. And that is some of what we intend to dive into today and some of the draft actions that were identified in that draft portfolio that was recently put out for public comment. And so we have a great panel of presenters to help inform us and the public and inform our subsequent discussions. We have invited Heidi Stiller from NOAA back to help facilitate our discussion, which we greatly appreciate. But before we get any further, we'll go to the next agenda item of approving the minutes. And do I have a motion to approve the minutes?
Motion to approve.
We have a motion from
Second.
Camille Manning-Broom. There's a second from
I'll
Mr.
second.
Daniels.
And Great Spring and Ben, the
Mr. Hart, I believe you're unmuted unintentionally, but any discussion, any edits to the minutes? Hearing none, any public comment? Seeing none, all in favor of approving the minutes? Say aye.
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 Any
Aye.
opposed? Nay. All right, we have approved the minutes. And so we will now move on to our next agenda item. I mentioned that we already have a great panel of presenters today, and I will turn it over to Ms. Stiller to tee it up for us.
Thank you, Harry, and good morning, everyone. It's nice to see everyone again. So I'll just quickly go over objectives for today and our agenda. We are going to hear from a panel of experts, as Harry mentioned, and we'll learn about the overall process of carbon capture, transport, and storage. Also, lessons learned from existing CCUS pilots. We'll talk about the economic and financial considerations and spend some time diving in on feasibility, liability, equity, and environmental justice aspects and concerns. And then finally, we'll focus in on the Louisiana context for development and employment of CCUS. We are going to hold Q&A until we've heard from all of our speakers today, but we do have a good chunk of time, at least half an hour, to ask questions of all of our panelists. I will say that just as we did last time, if we can't get to every question, please go ahead and make sure your question is in the chat. Lindsay will compile those and follow up with panelists if necessary. Also, just a reminder to each of our speakers, we are trying to keep to a tight time schedule today. So if you're running over your 10 minutes, I will be jumping in just to ask you to wrap it up. And with that, I'll turn it back to Harry to kick off our panel.
Thank you, Heidi. And so as Heidi mentioned, we'll run through all of our panelists, but I'll introduce one at a time. And we will be starting with John Thompson with the Clean Air Task Force to just go over CCS basics and introduce this subject for everybody.
Well, good morning, everyone. Appreciate your being here today. I'm going to share my screen here and show some slides. Give me a moment to just get set up here. Yep, getting close, excuse me. Okay, let me ask, can everybody see something that looks like a PowerPoint that says overview, the process of capture, transport, and storage? Good.
Looks good.
Thank you so much. So a little bit of background about what I'm going to do today. I'm going to only talk for about 10 minutes. So Heidi, please keep me on track, because as the first panelist, I know that if I get off track, everyone gets off track. A little bit about the Clean Air Task Force. We're a nonprofit environmental group. We have staff, about 60 staff globally, spread over about 14 time zones. You'll see in the background here, my video, there's Casey the cat. She's the cat of CATF. She tends to join me on occasion, but I hope to keep her out of most of this. Our mission really is to create an affordable zero carbon energy system. And by advocating pragmatic policies and new businesses, strategies and advanced technologies, and the one I'm going to be talking to you about is carbon capture. What we would like is to meet the world's energy demand in a way that's financially, socially, and environmentally sustainable. And all of our funding is philanthropic. It comes from either individuals, grants from private foundations. We don't take any corporate money. So my background, I'm a chemical engineer by background. I've been working on carbon capture for about 20 years. And as I think Harry described earlier, carbon capture is an important tool, but it's not the only tool. And when you look across Louisiana, particularly on the industrial and power sector, the industrial side, you're going to need to electrify certain things. You're going to need to use hydrogen for some high temperature applications, and you're going to need carbon capture as well. It's not the only resource you have, but it's a significant one. So what I have here is a map that I compiled from US EPA's flight database from 2020 emissions. You see refineries, it's about 26 million tons of CO2 each year. Those are sources that produce more than 100,000 a year. I've excluded everything that's smaller than that. Pulp and paper, the green dots is about 2 million. Power plants, the yellow dots, the light colors, about 35 million. Petroleum, about 15 million metric tons of CO2 per year. Metals, around a little under 2 million tons annually of CO2 emissions, and chemicals, about 37 million. I really don't see how we address Louisiana's emissions without carbon capture and storage. It's just a fundamental tool. The numbers are huge. Between Texas and Louisiana, you've probably got about a third of the nation's industrial emissions. So what you do here really matters. So what I'm going to do is just talk briefly about the capture side. I'm going to leave Steve Whitaker and others to talk about transport and storage. CO2 removal, capture really does two things. It can remove CO2, that's its primary purpose, but it also reduces some criteria pollutants as well. And historically, these capture systems have been designed to do about 90% removal, but that's really an artificial limit. The IEA, the International Energy Agency, says there's no reason why you can't get up to 98 or 99% capture. And even as mentioned earlier, Air Products, hydrogen and ammonia plant announced in Louisiana last week will do about 95% capture. But in order to do this capture, most of these systems rely on something called amines. It's a chemical that interacts with the CO2 and pulls it out. There's a lot of things that amines don't like, and a lot of those criteria pollutants are the same ones that cause human health problems. SO2, for example, is strongly associated with premature death and disease. Particulate matter, the same thing. These things are not only bad for the air, but they interact with the amine and degrade them. So you have to basically remove almost all of the SO2, particulate matter, some species of NOx, particularly NO2, sulfur trioxides, and many metals. And you have to do that to protect the amine so it does its job. So that's a co-benefit. You get these massive removals. You basically virtually eliminate all of the SO2 in these things. And I mention this because I know many people in the audience today perhaps live near the fence line of many of these industrial complexes. And I think that carbon capture moves us in the right direction on CO2 removal, but it also moves us in the right direction on removing some of these things that are harmful in our communities. So let me talk briefly with an example on Petronova. Just how does this stuff work? So Petronova, as some of the other panelists are going to describe, is a carbon capture unit on a Texas power plant, the Parrish plant. And this operated for 3 years. It's closed right now. But what you see, that arrow points to a duct that carries the CO2 from the power plant from a slipstream of about 200 megawatts of flue gas out of the 600 megawatt plant. It reaches this area here, a quencher that removes all of that SO2 and particulate matter. What happens next is this enters an absorber tower, what I've got circled here. The amines go in the top, the flue gas out the bottom, the cleaned emissions come out of the top. Next goes into a stripper where you see here on the circle that amine CO2 liquid is heated up. The CO2 comes off the top, the bonds are broken. The remaining amine is recirculated back into the absorber, and then it gets compressed to about 80 atmospheres. And at that point, it's no longer a gas, it's kind of in a supercritical fluid phase. It's both a liquid and a gas. And at that point, it goes into a 12-inch pipeline. All of that equipment, $500 million worth of equipment, basically aimed at putting this into a 12-inch pipeline. So I want to just, conclude with a couple of passing studies here. One is that Mitsubishi Heavy Industries announced yesterday, actually today, test results for their Mongstad facility, the KS-21 facility that solvent. They used this is the same equipment that was used at Petronova, only this is a newer solvent, getting 95 to 98% capture from that test results and achieving 99.8 under certain conditions. You're going to also hear some different views on how much is captured at Parrish. I say it's 90% based on the reports that were filed by DOE. Some of the panelists are going to use different numbers, and I can explain to you where, the difference between those. But basically, 92% of the CO2 that passed through the capture unit was captured. And this is a link to that report that'll describe some of those things, and also what wasn't captured. What wasn't captured was some of the emissions to power the capture unit. And finally, some links to reports that describe what we might see in terms of cost reductions in the future. Finally, I just would say that why haven't we done more carbon capture in the past? Well, it's expensive. I believe Dane will talk about the source of these studies here, but essentially we haven't done a lot of carbon capture because the tax credits, 45Q, that we rely on are only about $50 a ton right now. And they've only been that way for about 2 years. And so what you see here are a lot of industrial and power applications that don't begin to be economic until about 85 or so dollars a ton. That's what's needed, I think, to drive a lot of this. So my time is up. Let me conclude my remarks and stop sharing my screen and hopefully keep us on track for the remaining panelists.
Thanks, John. That was great. Harry, do you want to introduce our second speaker?
Sure, and thank you, John. Really much appreciated. And so next we'll move to the next agenda item, and the next three panelists will really dive into opportunities, challenges, and lessons learned. We'll start first with David Schlissel with the Institute for Energy Economics and Financial Analysis, pardon me. And so the floor is yours, David. It looks like you're pulling up your presentation. David, yes.
Oh, I thought I was going in the second group.
Yes, you are up if you're ready.
I'm on if I'm ready.
Yes.
Okay, I'll just move my breakfast out of the screen so I can have some space. Give me 1 second.
Okay.
Oops. I'm actually having a bit of technical difficulty this morning. Can you move on to someone and come back?
Sure. Let's see. Carol Muffet, are you ready to? I know this is a little out of order, but would you accommodate us? You're on mute.
Certainly, I can go. Give me a moment to share
Yes,
my
sorry
screen.
for, no, you probably needed a few minutes to heads up, but thank you for, and then we'll move to David after Carol.
Give me just one moment to adjust the display settings. All right, you should now be seeing a full screen presentation. Is that correct?
Yes, thank you.
Thanks. I am Carol Muffett, the president of the Center for International Environmental Law. I am honored to be able to speak with the task force today on this critical issue. If you remember one thing from the next 10 minutes, I would like you to remember this video that shows what a CO2 pipeline rupture really looks like.
This video shows a rupture of a buried, dense phase carbon dioxide pipeline. The experiment was conducted in the safe environment of the DNVGL Spade Adam Testing and Research Centre to assess the consequences of such ruptures in terms of mass outflow, crater formation and dense gas dispersion. The viewer should note that the extent of the visible plume does not necessarily represent the extent of the dense gas hazard.
I share this video with the committee because while the promise of carbon capture and storage is largely illusory, its impacts will be very real. And one consequence of this is we are seeing rising opposition to CCS and CCUS across the United States, across the Gulf, and worldwide. The White House Environmental Justice Advisory Council has spoken out about it. The world's largest network of climate-oriented groups has exposed it as a false solution. More than 200 organizations with the Gulf South for a new Green New Deal have opposed it, and hundreds of organizations across North America have called on leaders to end the carbon capture of climate policy because CCS doesn't work and it's dangerous. It's important to recognize that the rationale for CCS that has long been relied on was that we needed CCS for new energy. And that rationale is increasingly being abandoned as coal and gas become less and less competitive with renewable energy. Bloomberg New Energy Finance now recognizes that roughly 80% of the US population, for roughly 80% of the US population, the cheapest source of new bulk electricity is renewables, wind and solar. As a result, the Energy Information Agency projects that 81% of new electricity generating capacity in the United States in 2021 will be from renewable sources, with coal builds being completely abandoned and natural gas new builds rapidly shrinking. Increasingly, in fact, renewable energy is not only outcompeting new fossil fuel powered sources, it's actually outcompeting existing not generating capacity from natural gas and coal. And those advantages continue to accelerate. And with that acceleration, the economic case for using CCS and CCUS in the electricity sector is largely evaporating. And as a result of this, what we're seeing is a shift in the narrative to justify CCS away from electricity generation and towards US industrial sector emissions. And it's true that industrial sector emissions are significant. In 2019, they accounted for 30% of all US greenhouse emissions when you include indirect emissions from electricity generation. But a team that included a Chevron researcher, and Chevron is a major corporate proponent of CCS, actually examined the viability of CCS for more than 1,600 industrial facilities across the country. First, they had to rule out more than 20% of all industrial sector emissions because those were simply coming from grid electricity and could be dealt with in other ways. Of those 1,600 facilities, only 656 were even potentially viable for carbon capture. And of those, less than half were within 200 miles of a feasible injection site. And those that were heavily concentrated in Louisiana and Texas, which is precisely why your state is being targeted for CCS deployment. But out of those 656, only 123 facilities, representing roughly 8% of the total industrial facilities, had any potential to capture CO2 cost effectively, even if the captured CO2 was used for enhanced oil recovery, which is to say to produce more oil that would still be burned, and even with full use of available tax credits. And even within those 123 facilities, many of the emission sources were not viable for capture. In total, out of 1,600 industrial facilities and more than 1.9 billion megatons of carbon, the researchers identified 68.5 million tons that were capturable. That's 3.5% of US industrial sector emissions. And if you're actually using that captured carbon to produce more oil, the climate benefits evaporate. And this is particularly important for Louisiana because the analysis showed that precisely the operations that are concentrated in Louisiana, refining and chemical production, include large sources of on-site emissions that aren't viable for CCS, even with full deployment of EOR and tax credits. And yet the proponents of CCS are looking to use these very small emission reductions to justify the build out of a massive network of new CO2 pipelines. The US currently has 5,000 miles of CO2 pipelines, overwhelmingly concentrated in the oil and gas fields of West Texas. Proponents of these technologies are looking to expand that to 25 to 65,000 miles of new pipelines that will be spread through communities around the country and heavily concentrated in the Gulf Coast. That concentration in the Gulf Coast is linked to both the intense petrochemical infrastructure that is already there and the fact that the Gulf Coast contains one of the few areas with potentially significant storage sites. This is really significant because one of the reasons Louisiana is being targeted is that communities across the state have been living alongside petrochemical infrastructure and natural gas and oil infrastructure for decades, and indeed for more than a century. And this is significant because despite its benign reputation, CO2, when it is compressed to the incredible pressures required for transport, becomes a fundamentally different and a significantly more hazardous substance. CO2 is an asphyxiant and it's an intoxicant. At concentrations of 30%, CO2 is lethal. At 15%, CO2 can put you into a coma. And at 5 to 10%, CO2 can so intoxicate you that you can't flee to safety and avoid more significant harms. And we saw the impact of this in February 2020, when a CO2 pipeline in a relatively remote community ruptured and led to 300 people in that community having to evacuate, more than dozens of people sent to emergency rooms and hospitals, and first responders noting that affected people were wandering around like zombies and frothing at the mouth. And this is really important to recognize because the next CO2 pipeline rupture that we witness is unlikely to be in a secure testing facility. It could be next to a school, it could be next to a community center, it could be next to a home. And even beyond those direct impacts from the pipelines themselves, there are the questions that arise about what you do with the CO2 after it's captured and transported. Note that 80% of all captured CO2 is simply used to produce more oil and gas, which is then burned, leading to more climate emissions. The other option is to inject the CO2 into saline aquifers, which I know is being considered in Louisiana. But if the pressure isn't carefully controlled in those aquifers, you get earthquakes, you get groundwater contamination, both from the CO2 and from the brine it displaces, and you face the risks of fractures in the caprock that can lead to releases of CO2 that are potentially both toxic and bad for the climate. The only way to manage those risks is to pump large amounts of saline brines out of the aquifers where the CO2 is being injected. And this
Carol,
is
I'm gonna just to give you a minute to wrap it up.
This is really significant because those brines are routinely toxic, highly hazardous to manage, and in many cases, they can be radioactive. Indeed, Louisiana has a particularly long history of producing radioactive brines from oil, gas, and geothermal wells because of the natural background radioactivity that occurs in the state. And thus there's unique risks that need to be addressed and considered with respect to how produced waters from CO2 wells will be managed. Finally, I will note that one other significant risk unique to Louisiana is that Louisiana has more than 100-year history of oil and gas production, which means more than a century of abandoned and lost wells. If those abandoned and lost wells are perforating the caprock in any area where CO2 leaks, the risk of CO2 reaching the surface or reaching groundwater aquifers is significant. And I'll pause there. Thank you.
Thanks, Carol. Appreciate it. Let's come back to David. David, are you prepared to present next?
I've gotten my act together. Yes, I'm ready. I'm ready to present. Okay. My name's David Schlissel. I'm Director of Resource Planning Analysis for an organization, a nonprofit called the Institute for Energy Economics and Financial Analysis. We have 50 to 60 staff around the world working on a wide range of energy issues. And let me share my screen. Oops, hold on one sec. Do you all see my slides okay?
We can see it, yes, perfect.
Yes, but can you put it in presentation mode or full screen?
That's up in slide. Sorry, I only have 2 degrees in engineering and I still find it difficult to do this. Okay now?
Perfect.
Looks good, thank you.
Great. My subject is some of the challenges to relying on CCUS for industrial decarbonization. Unfortunately, in 10 minutes, I can't get to all of them. So I've tried to select some of those I think are the most important. This is the orange reddish circles are the operating facilities, carbon capture facilities in the world. Significantly, I would note that there's only one steel plant and none that capture CO2. It's cement plants. These industries may not be highly relevant to Louisiana, but they are relevant in terms of the portions of the industrial CO2 emissions from the United States. There are 3, even though proponents will cite, as on the left there, that 40 million metric tons of CO2 are captured annually. There's key information that a task force like yours needs before determining how much of a contribution you can expect CCS to make to reducing CO2 emissions. Only 3 of the projects have reported what percentage of the CO2 they produce is actually captured, their capture rates. Only 2 have discussed in any level, whether detailed or not detailed, the types of equipment problems they've experienced. And only 2 have reported, even indirectly, any question about their profitability. In terms of a target rate, 90% capture rate is the holy grail for carbon capture. But the lower the capture rate, the more CO2 is emitted into the atmosphere, obviously. These are 3 facilities that have reported on their capture rates. The Quest facility captures CO2 from the tar sands development in Alberta. The other 2 facilities are power plants. You can see that none of the 3 has captured 90%, but if you listen to proponents of carbon capture, they will be talking about 90 to 95% capture. Excuse me. And we have no evidence that that's been achieved anywhere. Another challenge is that there's a wide range of, for many industries, there's a wide range of projected costs. You can see the power plants are on the left. That's a natural gas combined cycle. The next one is a coal-fired power plant. And then there's a series of industries with a wide range. I should mention the Global CCS Institute is a promoter of carbon capture, and I took this from a recent publication of theirs. So cost uncertainty. Now, proponents of carbon capture are going around claiming that the costs have been too high and that they're declining. But there's no evidence that they're actually declining. They use this chart that you can see here, and I'll briefly explain that the only 2 actual plants, whether power plants or industrial plants, whose costs are reported, are the ones with the red dots, red circles in the middle, Boundary Dam and Petra Nova. All of the ones on the left were studies of facilities that never got built. All the ones on the right with the lower costs are projections for future projects that have not been built, so they're not tested. No way to know what their costs are going to be. But by drawing these lines, you get a sense of, wow, the cost is going down. One other point I'll mention before I move on is that these capture costs are just that, capture. They don't include the costs for drilling, compressing, transporting, injecting, and monitoring the geologically stored CO2. We've seen an estimate of $20 to $25 per ton to the total cost of carbon capture from these essential functions, but that's only an estimate. Yesterday, I received some actual costs from the Quest project up in Alberta, and it's much higher than the $20 to $25 figure here. Other challenges. Timing. Once again, the summer has proven we've got to take action as soon as possible. While CCUS or CCS may ultimately perform a major role in reducing CO2 emissions, it's not going to happen immediately. It's going to take time to design, build, test, and then bring a new industrial CCS facility online and demonstrate that it's functioning effectively and reliably in reducing CO2 emissions. It can be expected to take at least 5 years, but possibly longer. So no new facilities should really be expected until the second half of this decade, if not later. Using complex new technologies can lead to unanticipated problems and unanticipated costs and unexpected problems during both construction and operation. Many of the CCS projects, industrial CCS projects, can be expected to be first-of-a-kind designs or even one-of-a-kind designs for a specific plant due to differences in industrial processes and or just the design of a plant. That would add risk. Let me go on. When you're looking at how much of a reduction in CO2 emissions carbon capture will provide, you need to look at where is the power coming from to run the carbon capture equipment? Where is the power coming from to run the compressors that are needed along the CO2 pipelines or for injection into the underground storage? If the power to run these facilities comes from burning fossil fuels, well, you got to calculate that in as an offset to the emission reductions. The previous speaker spoke about enhanced oil recovery. It significantly reduces the benefits of capturing CO2. And then finally, there are a number of legal and political issues that need to be addressed when you're thinking about CCS. The first is, will communities, farmers, and ranchers be willing to accept the siting of the large number of new pipelines that can be expected to be needed to transport captured CO2 to underground sites? Again, this may not be a problem in Louisiana. Communities all around the nation are objecting to new natural gas pipelines, which are roughly 1/4 the size of CO2 pipelines, are at much lower pressures. The last question, and it's a key one, is who's going to be responsible for monitoring and preventing leakage of the stored CO2 underground, and who's going to be responsible for the liabilities associated with the damage from leaks? If a leak creates the kind of damage that the previous speaker showed in his video, there could be a lot of money from direct from damage, but also from having to pay back to the federal government for tax credits that have been given to the owner of the facility for capturing CO2. A number of projects I'm aware of in New Mexico and North Dakota are asking the states to bear the responsibility for leaks. This could
David,
be
I'm gonna
hundreds
jump
of
in.
millions of dollars, and I'm done.
Perfect. Thank you so much. Back to Harry to introduce Steve.
All right, thank you, David and Heidi. And so the last person on this section of the agenda is Steve Whitaker with Illinois Geologic Survey. Steve, the floor is yours.
Hi there. I can't share yet until there's somebody else sharing the screen right now. It's a message.
Oh, I'll go
There we
ahead.
go. I just opened it up, so Steve, you should be able to upload.
Okay. Well, thank you very much for having me on this panel. I really appreciate the opportunity to speak. And what we're going to tell you about is some of the lessons we've had here in Illinois. And why Illinois? Well, I guess I should introduce myself. I'm with the Illinois State Geological Survey at the University of Illinois, and I'm the director of the Energy and Minerals program here. And we've had a history of doing carbon capture storage related projects now for over 20 years. Illinois is situated in a geologically favorable area, which is part of the reason why we've been the focus of this activity, but there are a number of places in the United States that are also equally suitable for this type of activity. And so this is our experience really on the road to CCS commercialization. And we've had a series of projects that I've shown in this arrow diagram, mainly related to funding through in partnership with the U.S. Department of Energy and many of their programs. The regional partnerships started in the early 2000s and have led to the regional transition to these carbon initiatives. So these are large programs that have engaged with a number of industry partners, universities, organizations of all sorts that are involved in CCS activities. A couple of these I'd like to point out. The Future Gen projects in green were several projects that had initiated. Some of them, they didn't necessarily go forward, but the Future Gen 2 project did drill a well and actually generated 4 Class 6 permits. And so I think most people on this call realize, but the Class 6 permits are what required to actually inject CO2 in a commercial project. Additionally, a couple of projects I'm going to be talking about during the course of this presentation is the IBDP, so that's Illinois Basin Decatur project, which stored 1 million tons of CO2 over 3 years, and the Illinois Industrial Sources project, which is currently ongoing. So it's an active site with injection going on today. There's also the Carbon Safe program, which is USDA-led initiative that we are leading in several projects, including a couple of phase 2s. One of those is related to blue hydrogen, and the Carbon Safe phase 3, which are also related to a coal-fired power plant and an ethanol plant. Those are still in process. So I'd like to talk a little bit about the technical feasibility of this, and it's been brought up. There are active projects that are ongoing throughout the world, including some here in the United States, that put together all these parts and have demonstrated that it is in fact technically feasible to inject safely CO2 and store it and monitor it. And so the Illinois Basin Decatur project was a demonstration project. It was designed to run for 3 years to store 1 million tons. And you see on this map, the lower green box is the outline of the project. So CCS1 is an injection well, it's shown in red. And verification well is a monitoring well that goes into the well. And I'll talk about these a bit more later. And it's in magenta. And then the GM1 is a geophone well. So it's a slightly shallower well loaded with up with geophones. The facility is the Archer Daniel Midland's facility. It's a huge plant. One of the aspects that they do is create ethanol. And so it's the ethanol, which is the source of the CO2 in this particular case. And the capture of that ethanol is about 99.9%. And so that ethanol is captured at the fermentation tanks, and it's a fairly easy type of CO2 to capture because it is so pure to start out with. And it's pipelined about 1 mile to the injection well. So this is really the extent of the CO2 pipelining in Illinois. So we don't have an extensive network, but certainly the indications are if there is going to be development of CCS, and we expect there will be in terms of either have development of hubs and so on, there will be additional transportation requirements. So the Illinois Industrial Sources project is shown just to the north. It developed based on the findings of the demonstration project. It also has an injection well and a verification well, and it's ongoing now. And it's nominally injecting about 1 million tons per year, but it depends on the amount of ethanol that's produced. And clearly, additional pipe infrastructure will be required, such as pipelines, that's identified. So I've alluded to the Class 6 permitting, and to date, there are 6 class permits that have ever been issued, and those are only been in Illinois. Only 2 of them are active. As I mentioned, the Future Gen 2 permits, they were issued, but they were never acted on, and they were withdrawn when the American Recovery Act funding had expired. But the well CCS1, which I just showed you in the previous slide, and the CCS2, both are Class 6 permits. In the Class 6 permitting activities, it's really almost a cradle to grave from before you start the activities. So all the geological characterization work needs to be put into a permit. You get a permit, you get approval to construct or drill your injection well. And then even once you've got that permit in hand, you still don't have permission to inject. So you drill that well, you do a considerably more work modeling and demonstration monitoring plan, and then you're given approval to start to inject. After the injection operation has ceased at some point down the road, you enter into a post-injection site care period, which is 50 years under the class year guidelines. And so during that time, you continue to monitor until you can demonstrate that the pressure has dropped off and the operation poses basically no risk. And so you can also demonstrate in the application that the risk will drop off considerably faster than 50 years. And if you can demonstrate that, you can have a reduced PISC period. And so we've had a 6-year PISC period for the demonstration project, which is now completed. And the other project has a 10-year PISC period. But this permitting has been an issue because it has taken so long to get. So in these particular instances, 3 years to get the issue to drill a well, and another 3 years after that to actually get permission to inject. So clearly there needs to be an acceleration for the timing of permitting for these things to go forward for a commercial sense, and it impacts the ability to realize the 45Q tax credits, which is the reason why the commercial entities would be going forward with this, and clearly it's a project risk. So what are risks? We've heard some identification of the risks in the previous discussion, showing an experimental release of CO2 from a pipeline. But the risks associated with CO2 storage really are around any kind of leakage. And those have been broached also with the legacy well bores. And so pre-existing wells that would penetrate your particular geological storage complex, which is the reservoir and the seal, need to be identified. And so for the most part, we choose these deep saline brine-filled reservoirs, which are quite extensive. They don't have other resources, and they've been penetrated by very few other well bores. And so ideally, that would be a situation that you'd like to look for. And identifying all the location of these and assessing their suitability is an absolute requirement to even get a Class 6 permit. So that needs to be addressed. There's also a risk of identified geological features, and those basically will all get encompassed in an area of review, which is related to the increase in pressure that the reservoir would see. And that would identify any place in the reservoir where there'd be enough pressure to push fluids or brines upwards into the next shallowest potable aquifer. And so that defines your area of review. Induced seismicity is also an issue. People are familiar with the issues in Oklahoma. It's a very different scenario in the case of CO2 storage. There's active passive seismic monitoring, which means these geophones, which I've mentioned earlier, are continually listening to activity. And if you see any kind of increase in activity, you scale back your injection efforts. To date, this is not, we have identified induced seismicity, as you'll see that in any type of injection or withdrawal activity in the subsurface, but it is something that has so far been at a very low magnitude. And the other issue is migration beyond the project boundaries. And I've shown here some modeling which show on the surface where the plume injection has started to increase. So you want to understand where this is. And migration beyond the project boundaries is more of a regulatory risk in which you may not get credits for storage. So you need to have a monitoring plan, and very well-defined monitoring plan in your Class 6. So the ability to monitor is demonstrated here. And this is an example of a cross-section of some of our modeling and monitoring work that has been done at these two sites. So these are both wells you see here are the injection wells. And this is a slice that has gone through a model which connects the two wells together. The verification wells or monitoring wells are also in here, but they're not in this plane. They're each about 1,000 feet from these wells, and they're able to collect samples. We have instruments in them which are able to monitor the temperatures and pressures, and all of those types of information can be fed back to our simulations, and we update those. It's a process called history matching, where you update your models, and this is effectively showing the distribution of the CO2 in the bottom part of this reservoir. Now, the well, this is about 1.5 miles deep, and the actual top of this reservoir is about double the height that you see here. So the CO2 itself actually never even gets to the base of the seal in this particular situation. but you need to, understand where these are, and this is part of your monitoring program. It certainly helps to identify the conformance of your activity, that is how well it's behaving within the guidelines of your Class 6 permit. And it will also be required for any kind of quantification and verification of storage. So the point is, you can monitor CO2 and understand where it is going in the surface. You have to understand the pressure, and you're allowed to only inject up to about 80% of the fracture gradient of the reservoir. So that's, you're well below inducing fractures into the reservoir. Another big activity that we have identified is, of course, the stakeholder engagement. And that is something that must be done fairly rigorously and transparently. So we really, there's a variety of different aspects. The project needs to discuss this with everybody, but there also needs to be a public stakeholder engagement regarding the programs that are out there, and also policy engagement. And I would understand that, this presentation and this panel is part of that. And so, this is the activity that needs to be done, and we have seen this done, very effective in many instances.
Dave, I am going to ask you to wrap it up.
Okay, so we do still need incentives to do this forward, and there's a societal demand for action. And I think the point here is that, as was stated earlier, CO2 is not the only capture and CO2's capture and storage is not the only solution. It's part of the bridge. So these are the recommendations. Stakeholder engagement has to start early. We want to cultivate knowledgeable stakeholders and be factual and try to limit the bias in the presentations, but also achieve the perceived risk. And one final point is that there really has to be support for the regulatory efforts and primacy, and that needs to make sure that there's the ability to properly administer these programs. So thank you very much for your attention.
Thank you, Steve. Appreciate it.
Thank you, Steve.
Back to Harry.
Sure, and I'll thank you for your presentation. And next, we'll be moving to our last panelist, Dane McFarland, who he's the Director of Research with the Great Plains Institute, and will be addressing CCS Louisiana applicability and opportunities. Dane, the floor is yours.
All right, thanks, Harry. I trust that you can all hear me. So the Great Plains Institute recently embarked on a 3-year study of regional CO2 transport infrastructure. The primary goals of that study was to identify near-term opportunities for CO2 capture retrofit, to locate areas of CO2 storage and use, and to model optimized CO2 transport infrastructure that would maximize capture and storage while minimizing the land use and the local impact of that infrastructure. And you can see some of our primary partners listed on this slide. A primary work product of that research was, on the left here, an analytical report we published in 2020. You can find that at the website below. We also engaged the Rhodium Group to do an economic and jobs impact study of the scenarios we developed in our research. On left, there's a Louisiana fact sheet also on that website. We have a number of other state fact sheets. And then on the right, a jobs and economic impact of carbon capture deployment fact sheet in Louisiana. So Rhodium Group, in collaboration with us, found a potential for 36,000 to 54,000 jobs around the US over 15 years, 7,000 of which could be in Louisiana. So our primary motivation, why I'm here today especially, is to address climate. And one thing that really guides us is international modeling from agencies like the International Energy Agency and the UN IPCC. Shown here is a carbon budget, the remaining carbon budget for the 1.5 degree scenario. We have about 420 gigatons remaining globally, which is about 8 or 9 years left of CO2 before we have to be at zero. Now that sounds pretty drastic. And it's true, time is running out for moderately achievable reductions. Delayed action past the 2020s will require extreme reductions, which according to the IPCC and others can only be achievable through negative emissions. You can see on the graph here, the dark gray line is really if we started now, but every year we wait is one more of those red lines. So the longer we wait, the steeper we have to decline. And really a decline that fast just is not likely possible without negative emissions like direct air capture, bioenergy, and carbon capture. Looking at a number of scenarios that the IPCC published for their 1.5 and 2 degree scenario, if you focus on the three graphs here, the first one being the P2 scenario on this graph, would require steep and early reductions in fossil fuel and industry. That's the gray area. But what's important to note here, this scenario does have very minimal use of negative emissions and carbon capture. But what it does require is that flip of that brown area, agriculture, forestry, and other land use, from being a net positive emitting sector to a net negative sequestering sector by the mid 2030s. But if we look around the world, we look at global development, we think that population is growing, especially in developing nations, that agriculture will continue to grow, that will continue to have deforestation in areas like Brazil. You might have something more on the right. In addition to industrial and fossil fuel sectors not being as quick to decarbonize as we would like them to, especially in the industrial sector, you see on the right, the P4 scenario would require much higher levels of negative emissions in yellow. Again, those coming from carbon capture, bioenergy, and direct air capture. So it's these scenarios published by the IPCC that has led them to say that meeting our 2 degree C warming goal would cost 138% more without carbon capture, and that atmospheric CO2 removal through direct air capture and bioenergy with carbon capture is needed, in addition to economy-wide industrial carbon capture. Now, it's that economy-wide industrial carbon capture that I'm focusing on today. So the industrial sector, as previous panels have said, has a high share of process emissions. So in sort of contrast to stationary combustion or energy emissions, process emissions result from the manufacture of products. They're not necessarily related to energy use, and they're often the result of a chemical process that inherently releases CO2. So they're hard to decarbonize through renewable energy or through electrification. And generally carbon capture and other new technologies that might not have been invented yet would need to be used. So to demonstrate that on the right, looking at various industrial sectors within the mid-continent of the United States, which includes Louisiana, you can see pulp, paper, oil, gas extraction, iron and steel, and petroleum refining have about a 25 to 36% share of that process emissions. Sectors like fertilizer production, industrial gases, cement have much higher share of process emissions that you can't decarbonize just with renewable energy and electricity. So going back to our study, we looked around the country at powered industrial facilities that would first qualify for that 45Q tax credit that other speakers have mentioned. So that's 100,000 tons per year for industrial facilities. And those are in the sort of darker gray teal dots here. And then we further looked at the operational patterns of these facilities to identify where might we break even on capital investment of CO2 capture retrofit in the near and medium term, so in the next decade or so. And those are purple or pink here. So high concentration, as other speakers mentioned, in the Gulf Coast, Houston, and Louisiana area. Zooming into Louisiana, I think Jeff had a great slide on this as well. Other speakers, we all kind of see the same facilities concentrated in Louisiana. So we identified 61 facilities in the state, totaling about 100 million metric tons per year of emissions. And then our near and medium term opportunities, we found about 23 million metric tons of CO2 that we could perhaps invest in today under existing economic conditions with expected CO2 transport costs and the current 45Q. So that's 23 million metric tons we could get started on today. Looking at storage, this is only geologic storage. This does not have enhanced oil recovery. This is permanent storage of CO2 underground, never taking it back out, never extracting saline brine, just leaving it in the ground permanently. We worked with the United States Department of Energy's National Carbon Atlas to look at these, the gray formations are nationwide saline formations, with the yellow and green areas being identified by Los Alamos National Lab and Indiana Geological Survey as being particularly low-cost opportunities for storage, so less than $5 per ton for permanent storage, injection, and long-term monitoring. Looking at Louisiana, so like other speakers have mentioned, Louisiana is seen as a great, having a rich resource in storage potential. We identified through that Scott model for low-cost storage opportunities, an annual technical potential of 2.3 billion metric tons and a total technical potential of 70.3 billion metric tons. Of course, these are scientific estimates, so reality may vary, and 2.3 billion metric tons, it would be the maximum physical potential, not necessarily an economic development scenario. And I would point out the difference in scale here. There's a potential storage of billions of metric tons, but we've identified in the near term 23 million metric tons in Louisiana, and our regional transport scenarios have identified about 48 million metric tons from throughout the Midwest that could be brought to areas of storage, such as Louisiana. So there's a order of magnitude difference here, meaning that the total potential for storage is actually thousands of years worth of CO2 emissions. Now, I want to note here that CO2 transport is a local issue. You need to develop that in an equitable way and pay attention to environmental justice. That being said, Louisiana, I think, has long been seen as having a great opportunity for doing more than its fair share in helping the industrial sector nationwide decarbonize and actually receiving a lot of credit, and in fact, tax credit and economic incentives for taking on that CO2. So that is an economic opportunity for the state, and it's an opportunity for the state to do a lot in mitigating climate concerns. My last slide here, Steve talked about this, and I think Steve knows a lot more about injection and regulation, but just wanted to point out some activity happening on the federal and state level, including in Louisiana. The EPA's underground injection control program and its Class 6 rule is a regulatory framework to ensure that large volumes of CO2 captured from industrial facilities, power plants, and ambient air can be safely, securely, and permanently stored underground. So this is the federal regulation regarding that. And it has requirements for well siting, permitting, operation, testing, monitoring, post-injection site care, and finally site closure. So that Class 6 regulation regarding injection for long-term storage in saline aquifers has been in high demand lately. EPA reports more than 50 Class 6 permitting inquiries. And EPA has been historically slow to respond because of staff capacity. So they have only recently increased that staff capacity to respond to permitting. But interested states may be able to act faster by getting granted primacy while following the UIC regulatory framework. And through the Carbon Capture Coalition and our Regional Deployment Initiative, GPI has actually worked with about 8 states that have convened around a memorandum of understanding about interstate collaboration and Class 6 primacy issues. So it's noted here that North Dakota and Wyoming have been granted primacy to regulate Class 6 through their state departments, such as the Department of Environmental Quality, Department of Natural Resources. It's generally treated under the water quality work of those departments. And Louisiana has applied for Class 6 primacy. And it's not final, obviously, but approval is expected in early 2022. I think state agencies could be a lot more responsive to local citizens and local social concerns than a federal agency. They could be have a lot quicker of a turnaround in response to concerns and issues. And along these lines, GPI is embarking on a series of equity and environmental justice initiatives that work with local partners to ensure the transition to a carbon-free future is done in an equitable fashion, so that we're bringing everybody along with us as we undertake the great effort to decarbonize our society and industry. And in Louisiana, I think there's wonderful groups like the Louisiana Environmental Action Network, the Deep South Center for Environmental Justice. Some of staff from those agencies might be on this webinar today, but we've been in dialogue with some of them and just to make sure that the people's voices are heard in this work. Because as you saw from the earlier IPCC slides, the international climate scenarios, it's going to be really hard to meet our climate goals if we don't do something for industry. You know, we need to have an option that's not just shutting down industrial facilities. We'd like to retain those jobs and the economic impact in these states, but we need to figure out how to decarbonize those facilities. So that's it from me. So thank you so much for having me on this panel today.
Thank you, Dane. Appreciate it. If you'll stop sharing your screen, well, that way we can get as many of the task force members up in our view here.
Am I off?
All right, you are. You're good.
Thank you.
Thank you very much. So we have just about a half an hour for Q&A for all of our panelists. And after that, we will take a 15-minute break as we did last time. And then when we come back from the break will be a time for the task force to have some conversation. So I want to open it up to task force members who have questions. I know that there have been some questions in chat, and of course, folks who are on the live stream cannot see all of that. So I will be leaning on you task force members to raise some of those things that were in the chat. And to that end, I actually am going to start with Rob Verchick. Rob, you had posed a question about whether subsidies would be required long-term. Do you want to ask that question so everyone tuning in today can hear the answer from John?
Yeah, let me make sure I'm open. Yeah, thank you. Yes, I asked John Thompson about that. My thought was wind and solar, the idea is they get subsidized early on, and then as they gain market share because of their own inherent advantages, they compete in the marketplace on their own, basically. And I asked whether that was the case with carbon capture and storage. And the answer that was in chat by John Thompson was that the idea is that you subsidize it, and then later on you put limits on carbon emissions, and that pushes industry to want to use it, even though it's more expensive at that point. Have I got that right, John?
You got it right. And I can go into more detail, but I think that's the summary. The main point I just make is carbon capture is a pollution control equipment. It's like nitrogen oxide, capture equipment like selective catalytic reduction or sulfur dioxide scrubbers. And the more you use it, the more the costs come down. And eventually, I don't think we'll be subsidizing CO2 capture equipment, over the long haul. I think what's going to end up happening is that we'll impose mandates that say, you can't emit, and people will either capture it or they'll electrify or they'll do many things. But until those costs come down, people are reluctant to do it. So that's why
Thanks,
we
John. Appreciate it. All right. Thanks for that, recapping that answer, John. I appreciate it. Colette, you have a question?
I do. Thanks, Heidi. I have a couple questions. I'm not exactly sure who they go to, but a couple of presentations talked about the facilities that have been identified. Someone said we have 61 facilities identified, sort of available for this. Can we hear a little bit more? Is this using the already in place industrial facilities? That's really my question. What is it that we're talking about? And then my second part was about the geological storage capacity. I'm wondering if someone could speak to if the increase in extreme weather, the erosion due to sea level rise, and what we're anticipating with sea level rise, if these things have any sort of impact on our ability with the storage potential. So the facilities, is it already there? And the storage potential, is the extreme weather and the climate impacts that we're already feeling, is that even being taken into consideration as we hear what the opportunities are?
Thanks, Colette. I see Dane wants to take a crack at that. I suspect a number of panelists will want to weigh in. So go ahead, Dane, kick us
Yeah,
off.
thanks. I'll respond to the first question. I think the 61 facilities was my number. So these are all existing facilities. Our work did not think about building new industrial operations. I can tell you that we looked at 11 refineries, 12 petrochemical facilities. There are 10 facilities which already produce hydrogen today, gas processing, ammonia, and some gas power plants. Those are the primary participants in our scenario for just how do we decarbonize the existing industrial facilities without shutting them down. Thank you.
All right, how about the other part of Colette's question? Who wants to take a crack at that?
I can address that.
Thanks, Steve.
So really regarding the geological storage capacity related to any kind of climate changes, it'll be basically insignificant to the change of the geological storage capacity because the reservoirs are very deep in the earth. We're looking at, everything basically a mile or a mile deeper with the geological strata that we look to access. Where you would be hindered is if there's a sea level rise and it basically floods the surface area, which would impact your ability to actually get to the wells where the injection would be, potentially you want to have the injection well located to drill down. But I should point out there are offshore storage projects in the North Sea where it's conducted offshore. So it doesn't impact the geology, but it will impact the access, maybe your ability to access a particular location to get to it. So in that case, there would be some diminishment perhaps, but the scale at which the time over that would have to be addressed, and it could be managed, but effectively the capacity in the earth will not be changed. You still have, and you would have to maybe drill your wells slightly differently.
Thank you.
Thanks, Steve. Anyone else want to weigh in on those topics? All right, other questions
Heidi?
from our experts? Yes,
sorry.
Camille, go for it.
Several people are asking for Liz's question to be popped up. Okay. What are the impacts and enormous build out of new CO2 pipelines to farmlands and our fragile wetlands? There are thousands of leaks from existing infrastructure in Louisiana due to Hurricane Ida. How would rising sea levels and major storms impact all the proposed CO2 pipelines and infrastructure? And I realize the second part of that is connected to Colette's, but this is, sorry, that's from Logan.
Thanks, Camille. Looks like Carol wants to take that one. And Rob, I've got you on deck.
Yeah, I think this is a really important question, and it is, it's a really complex one because I think it's really important to recognize that the impacts of those pipelines, as I noted, the impacts will come from the significant risks of leaks and ruptures that could affect surrounding communities. It's also worth noting that in the event of a CO2 pipeline rupture, much more CO2 would be released more quickly than in the event of an equivalent natural gas rupture. And so you're going to get much more gas much more quickly. And natural gas, as dangerous as it is, it's really worth noting that natural gas is lighter than air. And so it disperses, it goes up. CO2 is heavier than ambient air when it's at those pressures. And so it sinks and flows into low areas. And I think this is a really important risk to understand. With the pipeline build out, you also get the direct impacts of building massive new pipeline infrastructure. Proponents of this build out in Louisiana have highlighted that Louisiana has a lot of legacy natural gas distribution infrastructure, but it's really important to note that those natural gas pipelines were never designed or built for the very different physical properties of CO2. And so what you're talking about is building a massive new infrastructure. And the final point that I want to make, and this is really fundamental, is that in capturing CO2 poses a significant energy penalty on both energy production and and chemical industrial processes. And that means you have to burn more fuel to get an equivalent amount of electricity out of the system, an equivalent amount of energy. And that burning more fuel, burning more feedstocks means massively increased emissions of other pollutants. And when people say that, oh, there may be a co-benefit in deploying CO2, that these other hazardous air pollutants are reduced, it's really important to note that what they're really saying is you can only apply and deploy carbon capture if you first remove those other pollutants. And so you could remove those other pollutants without ever deploying the CO2. And nothing about removing those pollutants addresses the fundamental reality that using CO2 requires more energy, which requires more feedstock, which increases the overall pollutant emission.
Thanks, Carol. John, it looks like you want to weigh in on this one as well.
So I appreciate the task force, willingness to share, a broad range of opinions and beliefs on the safety and efficacy of carbon capture. I'd like to just address some of my views on transportation. And I'd like to anchor it in some numbers. For 36 years, over the last 36 years, the federal government compiles statistics on hazardous liquids and how they're transported. And there's been, over that 36-year period, 10,600 incidents of leakage from these pipelines. Only 95 of those incidents over that 36 years were related to CO2 pipelines. It's just a small fraction because the safety record is extremely strong. I mean, you have CO2 pipelines in Louisiana. Now, this doesn't mean that we should ignore safety. Safety is critical, and we need to always be looking for better ways of improving pipeline safety. And, a lot of these ruptures and things, the pipelines are controlled so that as soon as a leak happens, they see it in a control room and can shut it down. And that's what happens. And I just want to, draw an analogy to power lines. In 2018 and 2017, we had power lines going through forests in California that ignited massive wildfires. 27,000 homes were lost because of those power lines fires. 2019, similar thing, people died, more stuff. That doesn't mean we don't do power lines in this country. We have to have power lines, but we have to do them safely. And I don't hear people objecting to the idea that we have power lines in this country. And I don't hear them objecting to the fact that we shouldn't have those power lines carrying, even if they carried electrons from photovoltaics or from wind, that we shouldn't have power lines. What we have to do is we have to build infrastructure safely. And I believe that we have a strong safety record with CO2 pipelines right now. That's the data. But it doesn't mean we stop with where we're at. It's unacceptable to have any ruptures. And we can all show, videos of explosions. We can explode CO2 pipelines and it looks awful. We can explode methane or oil ones, it looks worse. We can explode buildings and it's scary, or planes and it looks awful. But the fact is that doesn't get us to where we need to be. If we want to address climate change, we have to be numeric about it. We have to be realistic and look at the tremendous work that's in front of us. And I would just argue that CO2 capture is safe, it's effective, and it's going to play an important role in places like Louisiana or in places like China and across the globe.
All right, thank you, John and Carol. I'm going to turn it back to Rob. Rob, you had some questions about the liability side of things.
Yeah, I mean, as a lawyer, I'm thinking about sort of the things that need to be done legally, and one has to do, as people have brought up, with the Category 6 permitting, which I'm not going to ask about right now. But the other thing that seems really important around the country is who bears the risk. John Thompson is talking about the presence of risk, and it may be small, it may be large, but the question is who's going to bear it in the future. And there are some who who believe that industry won't get involved in this at all unless the state assumes all the long-term risk of possible explosions, leaks, asphyxiation, and all of these other things. And so my question to Steve Whitaker is, how important is it for industry? How important is it to industry that the state assume future liability of the things I mentioned? And if it is important, what's the argument? Because it would seem to me that industry knows more about about the activities, and they have more control of the activities than the state does.
I think it's more important as much for industry to understand how that will be dealt with eventually, and it's not always clear who's going to accept the liability. For example, at the Archer Daniel Midland site, they currently are responsible for the behavior of that CO2, the long term. It's not going to be necessarily.
And that's indefinitely, you're saying?
That's correct at the moment, and I think at some point Illinois will have to evaluate these scenarios and understand whether or not they'd be willing to take over that liability. Some states have said they will do that, but effectively the liability would not be transferred to a regulatory authority or whatever it would be until the site has been demonstrated to have minimal risk, essentially no risk. And
why would you need to transfer? I'm sorry, why would you need to transfer the liability if there was no risk?
Because at some point the company may no longer exist, and there may be an orphan situation where a company is operating this, it doesn't exist anymore, nobody's responsible. So at some point it would be responsible for the state to assume some sort of ownership on that project. Now that can be taken in a few ways. There can be a fund that would be going into that to establish, at some point the company is paid for it, but it'll be managed, that fund will be managed by some authority, whether it's a state or some kind of oversight body. And
so kind of a super fund situation where I'm thinking, would that be sort of like a super fund situation? We hold companies liable now, even for hazardous spills that might have occurred 100 years ago. And if they're orphaned, we have a federal program that allows for liability and in some cases a fund for cleanup. Is that the sort of thing you're suggesting?
Potentially like that. Some states have orphan well programs, so companies will pay money for the wells they drill to make sure that there's a fund available. So it could be in some form like that. And I think it's probably in the interest of a state or a regulatory area to somehow address whether they would at some time assume that responsibility. But like I said, that responsibility would not be transferred until there's effectively really no risk, because that post-injection site care period, which is 50 years in the Class 6 regime, would still be under the responsibility of the operator. And in that, if it's not after 50 years, it's still not at a low level of risk, then that period would be extended.
So that's something that the lawyers among us, anyway, that's something we should probably be thinking about, is how to develop some kind of a super fund compensation program after liability ceases from the companies.
And why industries kind of balk at this and why they would like to see some is this this perpetual responsibility, and they would like to see some kind of closure, I guess, at some point once it's been established that the project is behaving as it should.
Thanks a lot.
All right, let's see. David wants to weigh in on this one as well. David, you're on mute.
Unmute. Okay. On a couple of points. First is, I doubt that any major emitter of CO2 is going to embark on carbon capture without one, significant federal subsidies to tax 45Q tax credit or federal loans. Investors don't want to put their own money into CCS because it's too risky. To the last question, in terms of liability, I just find it hard to believe that any large company is going to risk its existence on the possibility of a major leak from underground or from pipelines. Looking at projects around the country, I deal with power plants, but I think the reasoning is the same with the industrial. They're not going to get built without the federal government paying money for a really long time. And we need to live with that where it's absolutely needed. As to liability, I'm sure the federal government or the state governments will have to take it. And I fear that local control over pipeline siting will be a thing of the past. If I don't know whether it was John or somebody else showed a build out of pipelines. Communities are not going to be able to stop those pipelines if the federal government decides the facility needs to be built. One last point, because I've been holding them in for a long time, is that you can't guarantee that the cost of CCS is going to go down. And I'll give one example. The cost of building nuclear power plants, they go up. Some technologies improve over time and others don't. And CCS, adding it to existing facilities is very complicated. And I would not bet my life or my future on it, the cost going down significantly.
All right, thanks, David. It looks like both Carol and John want to weigh in as well. Carol, we'll start with you.
Yeah, and I just wanted to build on that fact. I think there's this widespread assumption that CCS is a new technology. It is not. The oil industry patented the technologies underlying this in the 60s and 70s. The oil industry has been using enhanced oil recovery since the 1970s. In 1980, an ExxonMobil internal memo said, we have the technology to address climate emissions, but we could cut emissions in half, but we won't do it because it's too expensive. And so proponents of this technology who say it's still maturing are ignoring the fact that industry has had access to these technologies for 50 years. Not only is it not yet economic, and I'm going to just push back on this because there's actually no evidence that it's effective at all. Project after project, including the Petronova project that many people have touted here, have failed. They've failed to deliver anything approaching the scale. They failed to be economic. They failed to work. They've failed. That's the history of CCS for the last 4 decades. And you're compounding that by adding pipelines, adding the risks that those pipelines bring with them, and locking in very hazardous infrastructure for decades to come. And I want to touch on one final point. Someone alluded to the fact that there have been only 90 leaks from CO2 pipelines in recent years. Yes, because there have been only 5,000 miles of CO2 pipelines. Proponents want to expand that to 65,000 miles. So multiply those 5,000 leaks by that number, and you start to understand the scale of the risk that we're facing. And finally, those 90 leaks have not been without impacts. People are injured every year, killed frequently by CO2 pipeline ruptures. It happens in oil fields, and so it's not. It doesn't get.
That is not fact. That is not a fact.
Carol, just
that's absolutely.
All right, jumping in as your facilitator, I am going to ask this to go one at a time. Carol, thank you very much. I am going to give John and Steve a minute to rebut. I do want to get to Flozel's question. Flozel, I do see your hand. John and Steve. John first.
So I'm going to start with what I was originally going to talk on. When there's such wide disparate views, I think it's often helpful to kind of do what I'd call the window test. Look out your window and see what's happening. There's a reason, if you look out your window in Louisiana, Air Products is proposing 95% capture on a $4.5 billion project. This is something that they've already committed to investing in. And so they wouldn't be doing this if they didn't think it was feasible to do 95% capture. They wouldn't be doing it if they didn't think they could do this without risk and without wrecking their balance sheet. Fact is, Air Products has been handling gases throughout their entire history. CO2 is just one of many gases that they deal with. And so it's not just in Louisiana. If you look in the Midwest across Iowa, Minnesota, South Dakota, Nebraska, there are companies proposing to build CO2 pipelines to gather CO2 from ethanol plants. Navigator wants to gather about 12 million tons a year from about 30 power plants and bring it into Illinois. Summit Agriculture wants to do the same thing in those same states, 30 plants, bring it to North Dakota. They wouldn't be doing this if they didn't feel it was safe at some level and if they could do it without incurring massive liabilities. I would just submit to you that the window test here shows what's occurring in our nation now. And the reason it's happening now is because in Congress in 2018 increased the value of 45Q from $10 a ton or $20 a ton for saline storage to $50. And that covers a lot of costs. ADM has been successfully capturing CO2 from its ethanol facility and injecting it safely. And I just want to be real clear. Carol, I apologize for interrupting you. That was rude of me. But there's been no deaths from CO2 pipelines. That doesn't mean that there haven't been accidents that aren't important, but there's been no deaths. And that's just the facts. But I do agree with you that we have to do a better job on the safety of pipelines. We must, and we will continue to do that. And it's especially important as we grow from 5,000 to 65,000 miles. But we have a track record that works, and we can build on that success. Thank you.
All right, and Steve, if I can ask you to keep it brief so we can get to Flozell, that'd be great.
Okay, I'll keep it brief, but I just want to say there are active, successful CCS projects out there. They've been operating for 25 years. Norway has an example in the North Sea. In Chevron, which was brought up earlier, has got a huge investment in Australia, where they're undertaking storage. And both of those initiatives there were both, if they wanted to go forward with some of their activities, they had to do carbon capture and storage associated with their projects. So there needs to be an incentive. There is no economics behind it now without, as John said, a policy driver, and that is key. But the ultimate, and with any industrial process, big industrial activities, there's going to be some risk. But the risks with CO2 pipelines on a per mile basis are demonstrably less than we've seen with natural gas pipelines. Still a risk, and clearly not to be dismissed, but I agree with John. There's been no fatalities associated with CO2 pipelines. So just to end up, the whole reason that this is being discussed is because CCS can reduce greenhouse gas emissions to the atmosphere. And that's the bottom line of what this is all about. So I think it can be done, and clearly it needs some political assistance.
Okay, thanks, Steve. All right, Flozell, last question goes to you, and then we're going to take our break.
Fantastic. Thanks, Heidi. And I really appreciate this vigorous conversation. First, a comment and then a quick question. I think, Mr. Thompson, many of us do the sort of window test as we drive around the state and in the communities we live in. And what we actually see is an industry or a set of industries and practices that are consistent with potentially making decisions that are harmful both to themselves and to community. And so we don't have time today to debate these issues, but there's a pretty consistent history with very specific and detailed instances of industry not making decisions, even in its own best interest, for the sake of profit, much less the people who live in those communities. So I just want to make sure that that is clear.
Well said.
My question, and I don't know if there's a way to answer this, but as I'm listening to this, and I really appreciate this focus on decarbonization and the merits or demerits of it, but this sits inside of a larger discussion about what is it going to take for us to get to success in the reduction of these greenhouse gas emissions and do it in a way that's not only equitable and fair, but that is going to save the lives of people in addition to save the planet. And can someone speak to the cost benefit analysis we only have so much money to spend locally and with federal incentives and in all the ways we're going to have to pay for the salvation of our planet. And it seems to me that I haven't seen a case made that CCS or CCUS is the most cost-effective way to get us there. It seems to be a source of minority. It's the most minority source of taking emissions out of the air, and it seems to present the greatest risk. And when you say that, people say, "Oh, well, you're just being negative, and you have to trust the technology." Some very well-founded and smart scientists and lawyers and others keep showing us that there's just no evidence, and I don't know why we're prioritizing this, especially from a cost-benefit perspective when we have better options. And it really is time, I think, we not only answer that question, but push the debate in that direction.
Thanks, Flozell. John.
First, of great comments, great questions. The IPCC that's been referenced in various presentations has looked at what the value of adding CCS is on a global scale, and it reduces the cost of getting to net zero by trillions and trillions of dollars. It's money that could be spent on education, money that could be spent on healthcare, money that could be spent on a lot of different ways. And I believe that carbon capture actually goes a long way to addressing that larger set of questions that you raise about what's happening on the fence line when you drive past industrial facilities. One of the real challenges I see is that for decades we've just said there are acceptable levels of toxic chemicals that can be emitted into communities, and I just don't buy that. What I think is kind of intriguing about carbon capture is that for the first time it's part of a solution that says we can get down to net zero, at least on one of these emissions. But why can't we use that same logic and move the goalposts on toxic air pollutants, on criteria pollutants, and eliminate those as well, and change the social license? I think carbon capture helps do that. It helps in two ways. One, it says we have at least this that we have to get down to zero. And secondly, it actually has co-benefits on many of those things. It doesn't do it all. I want to be clear, it doesn't do it all. But I think if it drives the conversation to the point where we're moving those goalposts to getting the toxins out of the air, it does it for all of us. And that's what my hope is.
All right, thanks, John. I'm going to do a last comment from Dane, and then we are going to have to wrap it up and thank our panelists and take our break. Rob, I'm hoping that your question is maybe something that the task force can discuss after the break. All right, Dane, take us out.
Thanks, Heidi, and thanks, Flozell, for the question. To me, this is not an either or. I do not pit renewable energy, renewable electricity, other solutions, energy efficiency against CCS. And to me, CCS is not inherently related to fossil fuels. CCS, to me, does not improve the production of oil. What we see from the IPCC themselves, and I'd encourage everyone to read the International Energy Agency's net zero scenario, which my reading of IEA's publication is that they went as far as they could to avoid CCS, to create the most minimal CCS deployment scenario possible in their net zero scenario, and they found it was still necessary. To me, the atmospheric science shows that we're up against a brick wall in the next 8 years, if you recall that carbon budget graph. We need every solution on the table. CCS does not replace other carbon solutions, and electrification, renewable energy, does not supplant the need for CCS, in my view, at least for industry. The only other option for many of these industries, cement, steel, we're going to need cement in the year 2050. We're going to need steel in the year 2050. And you can electrify and use renewable energy as much as you can in those processes. You still have chemical release of CO2 that will need to be captured. And that's why we need to figure out in the near term, where can we apply CCS if we're not going to be shutting these industries down? Thank you.
All right, very good. We have to stop. We've run a little bit over, but I really appreciate panelists sticking with us and answering questions. task force members, if there was a question that you had specifically for the panelists that we did not get to, please be sure to enter that in the chat so that Lindsay has a record of it and can follow up with our panelists. Let's take a 10-minute break instead of 15 to maximize our time for discussion. So it's 10:50. We'll take a 10-minute break and reconvene at 11 a.m. See you soon. folks are coming back, if you can turn on your camera just for a minute. So I know you're back. That would be great. We'll get rolling here in just a minute. All right, I've got a couple minutes past the hour. It looks like quite a few folks are back, so we will get rolling here. So we have about 45 minutes for conversation, and that will leave us time to have our public comment period at the end. I'm going to do something same way that we did it last time around, where I'm going to ask you all a discussion question and ask you to just take a minute and think about it and think about how you would answer the question. Jot down some notes if you need to, and then we'll start sharing. And the reason we do this is that if we just jump right in, then we tend to just build off of whatever gets said first. This way we can all sort of think about how we would answer the question. So our first question, and we're going to ask you to think about today and also think back to our first session. Given what you heard today about the opportunities and concerns around CCUS, and given what was learned in the first session on the 4 pillars of decarbonization, how are you now feeling about CCUS as a piece of the overall decarbonization strategy? So thinking about what we learned today, sort of pros and concerns, also hearkening back to our first session where we talked about other aspects of decarbonization, the other pillars. How are you feeling about CCUS as part of the overall picture? So just take a minute, jot down some thoughts on a piece of paper if you want, and then we'll start sharing in just a minute. All right, I see some folks are still writing, but it looks like some folks are ready. So I will ask you to raise your hands, and I'll do my best to call on folks in the order of those hands. I know nobody wants to go first, but who's brave enough to share some of their reflections? Harry.
Thank you. So I think it was a very good discussion that we had first off earlier, and I think helped clarify some things and at least identify concerns that folks have. But I would just say that given our GHG profile, with a majority of our industry or of emissions coming from industry, and significant amounts of that either can't be electrified because they're process emissions, or as we learned last last week or a week, 2 weeks ago, that the technology to electrify is still very much in development, thinking about high temperature boilers and things like that, that we need to keep CCS in the toolbox, and it is an important tool in the toolbox for reducing those emissions, especially because we don't have time to wait until 2030 to start thinking about electric boilers for the high temperature. We need to do something about process emissions in Louisiana, and so I think that is it's critical that we also make sure that public is engaged, informed, and that we are regulating as safely as possible, and that we are increasing resources for our regulatory agencies to do to oversee and regulate pipelines, wellheads, injection wells safely and transparently. And so I think that is that is what I've gleaned from the conversations both today and from 2 weeks ago. So I just offer that.
Thanks, Harry. Rob.
I really appreciated the conversation. A number that just sticks in my head from the inventory is 136 million tons of carbon coming from industry. And I'm trying always to figure out how much of that in 10, 20, or 30 years can be captured and stored. And we keep coming to a number, the Water Institute's tool, I think, was around 15%. Dane McFarland gives us a number about 18%, understanding there's huge uncertainty in these numbers. But what that suggests to me, which is incidentally 12% of the state's total. So if this is an industrial pillar, this is an industrial pillar that, looks like it's capable of handling about 18%, which means that the other industrial pillars, the other 4 or 3, whatever they are going to have to support 82% of our structure. And I just wish we would spend the same amount of time talking about those pillars as we do about this pillar, because it kind of seems to me that we're spending 80% of our time on less than 20% of the solution. And I know there are lots of other things that we've been discussing, but we haven't had a full morning to discuss cap and trade or pricing carbon or all of the other things that need to go into this. And I think this maybe is Flozel's, maybe it's another way of rephrasing for me what I understand Flozel to be concerned about, which is if we have a limited amount of money, taxpayer money, and a limited amount of time and resources and political capital, why would we spend it on 18% of the solution as opposed to 82% of the solution? That's all.
Thanks, Rob. Others want to react or share other reflections based on today in our previous session?
I'll just offer a reaction, just because I agree with you, Rob, that we are spending a disproportionate amount of time on CCS, but I think that is because there are strong feelings about and concerns about that, and it is less, I think, known by the general public about what it is. You say CCS, I would say most people in the public don't know what that means, and so I think it is important as an education component, because most people generally understand the concept of renewables, and solar and wind, where while I would love to spend a full session on renewables and think that could be valuable and informative, it was limited amount of time and limited amount of meetings, and wanting to address what I think are conversations that are being had, and wanting to bring them to the fore and have a public conversation about something that I think is concern, folks have expressed concern about. And so that was the intent of holding this meeting. And similarly, I mean, it's a little bit different, but industrial emissions are majority of our emissions. And so that's why we had the meeting 2 weeks ago. focusing on industrial emissions and how to grapple with that, because it's less intuitive than perhaps the power production or transportation.
Thanks, Harry. Other thoughts?
Heidi, this is Flozell. I have my hand raised. I don't know if you can see it.
I missed it. Please go for it.
No problem. One just to just an affirmation of Rob's point. I think he more eloquently captured what I think is one of the most essential questions that we really need to answer. And it's not only how can we have a fair sort of discourse about all of the different options so that we can have a true comparison. But I also think it's fair that we are here to some degree because carbon capture and sequestration, CCS and CCUS, are major points of activity that have been moving forward, I would say, long before this task force was put together, right? And so there is a set of actions and activities that to some degree we're responding to that is not commensurate in the other areas of opportunity, in the other pillars. And there's probably an opportunity there for us to deal with that. I'm thinking to your question really also about some of the questions that were asked earlier that I don't think we have either adequate answers for or that we have more work to do. And that's namely, who's going to be impacted by this beyond the larger global conversation about greenhouse gas emissions? For those of us who are fortunate enough to get to work at the community level sometimes, the people we see and the conversations we have and the experiences we have ourselves and in our families include really some tough parts of this conversation that have been difficult to have. And it includes people being made sick by the air and the water and the land that have been poisoned in their communities. That is directly tied to a set of actors who we are now being asked to believe, who we're being asked to trust by way of their industrial intents and the science that they're putting behind it. We are being asked to trust that decisions about sites and primacy and all of the complexities of the regulatory regimes, as was pointed out earlier, are going to be managed in a way that are fair to people when we just don't have any evidence of that by way of our the proof of history, as someone once said, and the current situation that we're in. And we're still not answering the larger question about how we're going to get to the actual original goals of this commission. And I get it, Mr. Chairman, we have so much emissions coming from industry that we have to have an approach to deal with that. I guess I'm just not seeing, by way of this, the scientific evidence. In a former life, I was a scientist, or the financial kind of cost benefit analysis, how putting so much effort and resources into this is going to remotely get us there, even as we're dealing with the ravages of intensified weather events like Ida, and the ongoing impacts of the BP oil disaster. And we could just go on and on and on. And so I'm hoping, Heidi, just by way of your question, that we can continue to probe and be inside of those discussions, that we can be polite when it makes sense, but also really push and challenge each other. This is, for many of us, the work of our lives. This is a pivotal point, not only in Louisiana's history, but in world history. And we're sitting inside of it. And this can't be just another exercise where we go to the least common denominator or to the easiest place because we don't want to do what imagination is calling us to do. and actually what the data and science is telling us we should do.
Thanks, Lizzo. Really appreciate those remarks. And I can see some folks nodding as well. Can we maybe dig in a little bit on some of the issues that Flozell has raised and maybe spend some time talking about the people side of the equation? Because I know in our first session we didn't have a ton of time for that, but today we do have some time. Colette.
Well, I appreciate the people side of the equation. I think it's been what's missing in this task force since the very beginning. We started off really hearing about the climate science. We started off really, putting our standards down around CO2 and GHG reduction. But we have really yet to acknowledge what is already happening in our great state to our great people. And I know I sit with folks who love all the things there is to love about Louisiana. And I'm saddened almost every time I'm on these calls to hear how little we talk about the people and the impacts on the people. I'm grateful for the presentations today. I have more questions than I have answers. What's in the CO2 brine? What's the long-term risk really gonna be to not just the ecology, but to the people who are living next to these facilities? But mostly I'm struck by the lack of accountability of the oil and gas industry. To hear that this is a 50-year-old technology, I was one of those folks who thought this was this unproven thing, but to hear that this is a 50-year-old technology that's being touted now to save us, but wasn't pursued until the globe was on the brink of burning and public tax dollars were on the brink of funding all of this. This just it doesn't feel right. To boot, we're talking about a technology that, if it works, and only after ravaging more of Louisiana's landscape for pipelines that will likely leak, because we all know pipelines leak, we're not unfamiliar to that. They will come online maybe 5 years into a 10-year countdown. And when it breaks, it'll break at a point of locations of all of these 61 polluting facilities, which are 80% of the time in Black communities and 100% of the time in poor communities. So actual human risk will be in the EJ communities. The real risks that we're talking about are the people that we keep forgetting to bring into the conversation. The economic risk will be for the public, and the damage to our fragile ecology, either because of increased earthquakes. I don't know if anybody heard that part, but I'm a little concerned, or just a general run-in with the extreme weather that we're experiencing. And this is more risk, more pipelines, more cost benefit analysis that concludes some communities are worth exposing more than others. This gives me great concern. It doesn't feel like Louisiana is doing its noble duty to the world to capture CO2 emissions. This feels like industry once again positioning itself to have the upper hand no matter the cost to our people or our planet. It feels like fiction. This piece of this decarbonization strategy feels too risky, too expensive, too one-sided. And it's about more than jobs and economy at this point. This is about our home. This is about our people. We should exhaust all the options for natural sequestration and all the other forms of reduction. We should not stop until we do all of that. And look at this money. Look at how much money we're spending on this thing that might create 7,000 jobs over 15 years. We should be honest about what it would mean not to capture byproducts of what is produced, but how Louisiana can stop producing the bad stuff altogether. We deserve a future with industries that don't harm us, that don't harm our families, that don't harm our environment. We deserve to imagine something much better than this. The innovation that can come out of this great state is, I think, better than what we've heard. The risks are here today. And I'm saddened because I think about those 61 facilities and we all know where they are. We all know where they are. This is where this stuff is going to be injected into the ground. I'm concerned. I'm concerned that we haven't learned our lesson and that we're still focused on a reduction of scientific stats as opposed to the protection and advancement of our people.
Colette, thank you for sharing. How are others feeling? I know this is getting at some hard conversations. I really appreciate folks being willing to share today.
I have some thoughts, Heidi. So on the one hand, I heard today that, and last week, there are technologies and new systems that are going to have to be put in place to reduce our emissions, and that there are statements around the safety of those, the deployment of those, the scalability, the efficacy of them. And then on the other hand, there are conversations and discussion points around the destruction and viability of those same technologies to the people, the land, and essentially our livability, getting at what Colette and Flozell were talking about. And so it's very hard for a layperson or for someone who is, whose job is not to focus on the technological pieces to understand which levers should be pulled, when, what policy components need to be added, and then really gauging what is the reality here. And so I wonder if a lot of people are grappling with this question. As Center for Planning Excellence, our organization is focused on helping communities enhance their quality of life and livability, which is increasingly challenging given the current decline of livability across our state due to climate vulnerability, due to second highest rates of poverty, economic shifts. And so when I think about the future of Louisiana and the future that I want my children to be raised in, and where what I want best for all of our community, I see something different, and I think we need to have a larger visioning conversation about who we are and where we want to go, and where we can have the most benefits for future generations. And so to me today was a lot of just raised more questions around the technology, more questions around the viability of scale and time. And so I'm left with, wanting to know more. So I really appreciate it. I think these conversations are really healthy. I applaud the governor and the governor's team and all the state agency representatives that are on the call. We are not going to get anywhere unless we have these hard conversations about the real truths, and come to a table and set policies together and uncover what's the best for the future of Louisiana. And so I just want to say I'm very appreciative of the discussion, and glad to be a part of it.
Thanks, Camille. Really appreciate you sharing.
Hey, Heidi, this is Tyler Gray. I just in listening to the presentations today, it does, it reminds me how complicated the issue is. And there's definitely a balance that needs to come with it. And, I talked a lot today about, also recognizing that there are, people have concerns about it. As we go through this process, I really do look to the way that Governor Edwards made his initial announcement of trying to balance everything from our economy to the people. And, as we've had these conversations today, I know that this is really geared towards a state plan and state analysis, but as we go through this process, and you recognize how complicated, and hearing, Flozell talk about the local perspective and things like that. But, this is a big enough issue where we're going to have to look at it and consider from a regional and national perspective too. It just adds to the complicated nature of what we're dealing with. But, and looking at it from that balance, and then the level of complication that comes with it, hopefully we will be able to identify options that will be, to meet those goals going forward. But there's definitely a complicated nature of it. It feels like there's still a lot of work to do on it. And because of the complicated parts of it, it requires a lot of, we have to consider a lot of different factors, right? I mean, you just have a lot that's going to be balanced as part of it. And, I hope that we're able to come up with something that's worthwhile.
Thanks, Tyler. Appreciate you sharing your perspective. Rob.
Thanks, and I appreciate everyone that I've been talking a little bit. But as a lawyer, I'm thinking about it this way. I think that, Colette and Flozell and others making this case that we really need to hear, this case about safety and human welfare. And I think what doesn't help is when the response, not that anyone's making this response, but what doesn't help is a response that says, yes, but we need to do it anyway because it's so important to decarbonization. I think the response that might be better is, we're hearing this and let's try to figure out how to solve the problematic parts. And maybe the problematic parts can't be solved. And so maybe then we're at a standoff. Or maybe some of them can be. I don't know the answer, right? But when I'm looking at my notes, one of the things that I see is Mr. Whitaker, for instance, talking about long-term liability. We know that's an issue. Now, it's a little strange. You've got industry saying there's no long-term liability, but at the same time, they don't want to be accountable for the long-term liability. They want the state to be. Even though we have Superfund laws and other laws that are capable of holding people liable for very long periods of time. But that as it is, what that suggests to me that any proposal from industry about CCS should contain some kind of long-term liability plan. Whether that means companies are going to be on the hook or the state's going to be on the hook with a taxpayer-funded compensation fund, or whatever it is. But that's something that needs to be presented, I think, to the community to say, what do you think about this? Mr. Thompson says that this has to come, CCS has to come with a cap on emissions. Because if it doesn't, that just means the federal government or the state government will have to be subsidizing this until the end of time, because there's no other way that it makes sense in a market. And so if that's true, right? And then what that means is that we need to ask industry to come with a proposal with a cap on emissions. So we know exactly how long these subsidies will go on and when they will be prepared to accept a cap on emissions. And I think some of the skepticism maybe around this is that these other kind of essential pieces to a CCS proposal are seem to me at least to be put off. Oh, well, we'll get to liability later, just give us this. We'll get to a cap on emissions later on. Or, the whole Category 6 permitting process. The reason that no state except for 2 has a Cat 6 permitting process is it's much more complicated. It's a different kind of a problem. That's why there's Category 6 and 5 categories before that. And so you can't just say, just give us this. You have to say, well, it's a special kind of category. Here are the things we as an agency are going to do to show you that we are capable of managing this Category 6 permitting program. We have to face it, we have state agencies that have been roundly criticized, even by the state, for their ability to implement and monitor and control permitting programs. And so it's not enough to say, just give us another one. I think what the community needs to hear is, give us another one, and here are the things we're prepared to do. Now, I don't know if any of that is going to break a standoff, but I think that it's the next step, because we just can't keep having this debate of we want everything, and then another side saying we're terribly skeptical. We need to have industry come in and say, we understand, here are the concerns you have, and so here we're going to propose something that shows that we hear what people are saying. And maybe that's acceptable and maybe it's not, but I think that that's the next step from my point of view listening to this. Thank you.
Appreciate it, Rob. Really appreciate sort of that looking at how can we actually advance the conversation on this. Much appreciated. Steve, I see you have your hand up. If you want to do a quick response to something specific.
Just very quick, I just want to make sure that within the Class 6 permit, there is a financial assurance component to that. So you have to demonstrate that your company has to demonstrate that they're financially capable of seeing the project through the post-injection site care period. And also, just to make clear that I was asked why industry wants the long-term liability. I'm not necessarily advocating one way or the other for it. That's simply the information that I know that they are concerned about. So,
and I didn't mean to mischaracterize you. So
I don't know if you did, but I just wanted to make sure.
Thanks, Steve, for saying that. Yeah.
Thanks. So, does Rob's reflection inspire anyone to sort of think about how do we advance the conversation about this? And how do we bring in those human welfare pieces to the conversation?
Well, Heidi, I guess the first question is, because CCUS is moving forward in Louisiana and already, it is a priority, I would think that the state has already moved on some of what Rob is talking about, and perhaps we can get an update and understanding on that.
And I'd be happy to just try to address that. So the Department of Natural Resources has submitted its application to the EPA for Class 6 primacy, which is still being vetted by EPA, as I understand it. And I think I saw in the chat that the comment period may have been extended by EPA. So currently, Class 6 well would be reviewed, a permit would be reviewed by EPA. So it is still in the EPA's court for any well in Louisiana today. And Rob, I certainly hear your comments and the comments made by Colette and Flozell as well. And we'll get more into this a bit more, I suppose, next week, looking at the draft portfolio of actions. But there was an attempt to incorporate some of that input that we've been hearing from the public comments and from committee members, advisory group members, relative to taking another look at the public trust doctrine, the regulatory safeguards that we have under Louisiana law, the IT analysis, and kind of putting a lens on it, and across state agencies that relative to permitting and siting of new energy infrastructure and technologies. And so certainly that is a broad statement, and it's getting into the details is where I think the meat of that discussion is, and it's hard to put in a paragraph description, but I think that's right for future discussion of this task force about how to do that, and in future public meetings around taking and revisiting our IT analysis and seeing what can be done under existing law, and if it can't be done under existing law, what laws would need to be changed. And so that's a role for this task force is to make those kinds of recommendations to promote public safety and welfare, particularly with these permitting and siting decisions. And then also increasing resources for our agencies that are going to have to do that, review permits to make sure that they're properly resourced. So I think that's another component that we need to, I think, budgetary constraints, limit the, the amount of time you can spend on, so you're slowing down the process. And so I think, additional resources are, would benefit our regulatory agencies, certainly as new permit applications and permitting regimes are being considered.
Thanks, Harry. Appreciate it. Virginia.
Yes. Oh, my hand here. I had a hard time dialing in earlier and changed offices to actually be able to participate here. Regarding the seismicity question and Colette's question and the concerns that that people have can only be alleviated with facts and science to support decisions. And the sedimentary environments that we have in Louisiana, we have growth faults. We don't have these hard rock potential for the same type of seismicity that you have in California. We have sinking, southerly dipping growth faults, and we have observed, and at the U.S. Geological Survey and at the State Geological Survey, we've been doing studies for years about growth fault activation. And we found in South Louisiana, a guy named Bob Morton, who worked at our St. Petersburg lab, he detected like differential settling on the sides of growth faults that was associated with extraction, not injection. So we do have some evidence there of influence on the land surface. And that's really of concern mainly in the coastal zone, where a few inches of difference can determine the long-term survivability of a coastal wetland. Another project we did years ago at LSU was we monitored the injection of large volumes of geopressure geothermal fluids into the subsurface down in Cameron Parish, the Gladys McCall well experiment. And what we did is we set up seismometers in the vicinity of the injection wells. And they were at depth. I mean, this is very deep injection. And we monitored for the whole duration of the injection of these large volumes of fluid, not gas, fluid in, and we detected very, the seismicity was couldn't be distinguished from the background, basically. So there have been studies of the and monitoring conducted in Louisiana. And, basically people will say, Louisiana's aseismic. Well, that's not exactly true. We do have the northern zone where we've got the New Madrid seismic zone in North Louisiana. There was a biggest earthquake I think ever recorded was down in Donaldsonville in 1930. And we have a national seismic hazard mapping project. So, you need information to support decisions and time to conduct that sort of analysis on these Class 6 well decisions. And what I would offer is that the science advisory group scope, Harry, exactly what you were just saying, what resources would be required and what questions might need to be answered before, the permits proceed and before we invest our future in this particular strategy. So just as a scientist and offering the support of the science advisory group, and I'm sure the State Geological Survey and the USGS would be willing to help, but it would take time, Harry. And as you said, there's resources, that can't go pull it off the shelf and hand it to you and say, well, this is the impact. But they are good questions and you do need facts. So anyway, just offer to help.
Thanks, Virginia. Appreciate it. So we have about 5 minutes left. And we had a second discussion question and you all moved right into it. Because we were going to ask about, how to ensure that equity concerns, air quality concerns, financial aspects, liability, right, could be accounted for in CCUS if it does move forward. And so, but the other thing we wanted to just circle back on was, again, just one more chance to sort of think across all 4 pillars of industrial carbonization and see if anyone has thoughts about sort of the balance between those pillars, thoughts about sequencing, timing. So I am going to ask that to the group, and keep in mind that you all will continue to meet and talk more broadly about your entire action portfolio. But just want to make sure we are having we want to share any thoughts that are top of mind while sort of our industrial decarbonization presentations are still fresh for us. So any other reflections from the first session or today? All right, and one more, and then I'll put you guys out of your misery here with me asking you questions. One more question though would be, looking ahead, the task force, will have its regular meetings continue. Sort of how do we use this, the 2 sessions that we've had on industrial carbonization to then build off of that? I think we heard today a desire to really look at the people side of things and to talk about how any of the 4 pillars could be pursued in a way that addresses human welfare. But any other thoughts about what you want to make sure the group continues to discuss?
Well, I just offer that as we look forward to next week, where it'll be the first opportunity of this task force to review the draft action portfolio, to keep these last 2 meetings top of mind, and also we will not have enough time to dig into all 99 or so actions, and so we can try to prioritize our conversation to address concern, focus on people-focused actions, as well as some of the points that Rob had raised, and we can try to craft our discussion, because we expect to have a decent amount of review of all of the public comments, all the advisory group, all the committee comments and feedback to help also inform the task force about kind of where the temperature of those folks on this draft portfolio. And Colette, I see your hand is raised.
Yeah, thanks, Harry. Going forward, I mean, I'm out of the country right now, learning about oil in the North Sea and the fights that are here, and it is very similar. But I did not hear about Louisiana's announcement until on this call, and so I think there were some comments and emails before to the task force about the foregone conclusion around CCS and why we're even having these conversations if Louisiana is going to go forward with it. But I do think as we go forward, with decisions that have been made even before our recommendations can go out to the public, we have to offer some space for the community to prioritize where it wants to spend its taxpayer dollars. We've got to shift the burden of proof, not on the community to prove that they would be harmed, but on industry to prove that they will keep people safe. We've got to, I really appreciate Dr. Burkett's intervention around the facts and the stats, and also just pairing that with something that we've got to study a lot more and look at a lot more and watch a lot longer. We've got to really balance out where we spend our time, energy, and resources on a clock that is ticking downward quickly. And so I would just say the forward motion on this technology and other decarbonization technologies have to, at least in their forward motion, shift their theory around what has to be proven and by who. And that burden and that accountability has to be absorbed by the industry, as opposed to us demanding that the community all of a sudden figure out all of this technology that many of us have had the space and time and staff help to understand in order to determine their future. I think we're getting to that point of unfairness now. And we're gonna have to see a shift. I wanna make just one last comment about our democracy. You know, what the average person has to know to participate in their future, especially in a new climate reality, and what we're talking about here and how we're moving even without, you know, community support, just on declaration and hope around technologies. I think this is a scary moment when the people don't have a bigger voice in what's going to happen with $4.5 billion in their community. And so I just, as we go forward, I think the priority has to be not on the people to prove what's not true, but on industry to prove, you know, what they will do to protect not just the ecology, but people's health, not just people's health, but our culture and our tradition. So I hope that can be part of our prioritization going forward.
Thanks, Colette. Appreciate it. So some really good points made and perspectives, and some conversations that can be picked up in your next meeting for sure. So thank you all for sharing today. I am mindful of our clock, so we are going to have to wrap up our conversation. I will turn it back to Harry for public comment period.
Thank you, Heidi, and thank you to all our task force members for engaging in this discussion, and for our panelists for taking the time to prepare and provide us with information that they can help inform our future discussions and recommendations ultimately. And thank you, Heidi, for again moderating this conversation. It's greatly appreciated. So now we'll move into public comments. So public comments will be accepted before and during the live stream of the meeting. Comments may be submitted via email to climate@la.gov. And if you so choose to email your comment, we will acknowledge those and read out the name of the person who sent those. And as we've been doing, append those to the official minutes for everybody to read. And if you are on the Zoom right now, you can comment verbally, and you can raise your hand, and we will call on you. And just want to note that we will limit to 3 minutes in the event that folks, there are a lot of people who wish to speak on this topic. So we'll first move with the verbal comments and go with Tim Supple. And Tim, I'm trying to unmute you. Tim, you have the permission to speak on the Zoom if you are there. Okay, we will move to Logan Burke.
Can you hear me all right?
Yes.
Wonderful, thank you. Good morning to the task force and everyone listening. I'm glad to see so many comments in the chat. We've heard today about promises made by planned CCS projects, just as the people of Mississippi were promised that the $7 billion boondoggle Kemper clean coal plant would provide clean energy and sequestered carbon, just as the Australian government was promised that the Gorgon LNG carbon capture facility would be part of that country's climate tools. Meanwhile, these promises and others have yet to come true. The projects failed, the costs were too high, the technology broke. Louisiana cannot afford to bet on promises. First, we don't have time to waste. The climate crisis is here now and is swiftly getting worse, and we need solutions that protect human safety immediately because Louisianans are already being harmed by storms and extreme heat and cold. Second, we cannot afford to bet on costs. Louisiana's poverty rate has remained around 20% for at least the last 2 decades. If we choose to put millions of our dollars into more promises, rather than solving economic and racial inequities and supporting a transition away from dangerous emitting infrastructure, we are continuing a centuries-long tradition of putting profit over people. I'd like to remind this task force of a presentation that was given months back that outlined how little of our emissions could be controlled by this technology. We're spending an inordinate amount of time and energy on something that even now only promises to solve for a fraction of our emissions problem. But the truth is we must stop emitting. Building new infrastructure that emits any new greenhouse gas emissions is steering us in the wrong direction away from zero. We heard about risks of earthquakes, groundwater contamination, toxic releases, ravaged wetlands and farmlands for enormous new pipeline systems. Can we afford to bet on something that threatens negative impacts and can only promise a sliver of a solution? Louisiana has a century of experience with oil, gas, and associated industries, and unfortunately, our state agencies and budgets have chosen to protect the economic interests of those industries over life, health, or safety of people. And if we choose to continue to emphasize and focus on this technology before addressing the fundamental needs of Louisianans, we are continuing to sacrifice our people and our future. Let us please focus on the no-regret solutions that can tackle more than a small percentage of our emissions and at the same time reduce economic and environmental inequities rather than double down on them. Thank you.
Thank you. We'll try to go back to Tim Supple, who has his hand raised. Tim, are you there? Any other public comment from those attendees on the webinar? And Tim, if you could, if you're having trouble getting off of mute, please let us know via the chat. Looks like you are now off mute, Tim.
Yeah, I don't mean to, I didn't have a question particularly, but if you're listening to me.
Yes.
The conversation I'm listening to seems to indicate that we have not yet reached a point where we understand the amount of subsidies that are going to be necessary to implement any form of carbon sequestration. So it appears to me that we don't have a market for it. We don't have a free market for it. We only have a market that we can create through subsidies. So I guess my question or comment to that is, what are you asking the people of Louisiana to adopt? That's it.
Thank you, Tim. Any other public comment from the attendees? Please raise your hand if you wish to make a comment. All right, seeing none. Lindsay, would you check our climate@la.gov website or email and let me know how many comments we have?
5, 6 public comments.
All right, well, because did such a good job on time management, Lindsay, if you wouldn't mind reading those aloud, just since we have the time.
Sure, yeah, absolutely. So our first comment comes from Grace Trefinger, and her comment reads, to members of the Climate Task Force, my name is Grace Trefinger and I'm from Bulbanca, otherwise known as New Orleans. I've been following the Climate Task Force as well as Governor Edwards' proposal of false climate solutions such as blue hydrogen, carbon capture, and sequestration. It has me extremely concerned for the future of our home and health and safety of Louisianans. Carbon capture is another false solution that allows petrochemical companies to continue extraction of oil and gas while often receiving subsidies to benefit from CCS. Meanwhile, communities suffer the dangerous and deadly consequences of CCS, such as predominantly Black community of Sartartia, Mississippi, which is the case study referenced earlier. I encourage the task force members who haven't read it yet to do your own research and determine that CCS does not serve people in Louisiana or anywhere in the world. Signed, Grace Trefinger. Our next comment comes from Michael Pellet, and his comment reads, carbon capture is another industry and government-led effort to appear to be responsible for climate. Yet the organizations who have led these efforts are not on the forefront of the decision-making process. Citizens must compete with industrial giants and financial strength to filter political contributions to members from both sides of the aisle. So after the mandatory comment period, they will still have industries polluting the air in Cancer Alley and still global industries along the river in the river parishes, while the people of the river parishes suffer for basic infrastructure. Until the political posturing ceases, our issues will continue with one more public comment to be routinely read into the record. But I say this, I am not deceived by the promise of jobs, and this is nothing more than polluters pushing CCS as a delay tactic, looking for profit off of it. Signed, Sage Michael Pellet. Our next comment is from Patrick Dario. His comment reads, Dear Climate Panel, Louisiana Climate Panel, I'm writing in opposition of plans to pursue carbon capture and sequestration at the expense of necessary steps to decarbonize Louisiana by stopping oil and gas industry dead in their tracks. CCS is a management tool that serves to placate the public and is pushed by polluters. While companies are continuing to emit tons of CO2 daily, pursuing CCS is not only a feel-good measure, does not do as much good as bailing out a boat while someone pours more water into it. Please take care to assess these solutions. We need real change to our energy infrastructure and a full transition to renewables, not flashy new tech that serves polluters. Thank you, Patrick Dario. Members, our next comment comes from Bridget Conroy, and her comment reads, to members of the Climate Task Force, I appreciate efforts made by the governor and this task force to address the urgent reality of the climate crisis. However, I urge both the governor and the task force to reject proposed plans for carbon capture and sequestration in Louisiana if the state allows petroleum and petrochem factories to emit the same rate they have been and continues to permit new ones. An expensive and unproven technology like CCS will do little to reduce overall GHG emissions. CCS does not remove CO2 from the atmosphere and is not a climate solution. There are also significant risks to carbon storage, as the White House Environmental Justice Advisory Council has described CCS as harmful to local communities in a recent recommendation. Carbon capture and sequestration amounts to little more than theater or delay against real climate action, ultimately harmful to residents of Louisiana. Louisiana's climate plan must invest in renewable energy production and rapid electrification. It must also halt permits for new CO2 emitting facilities and hold polluting industries accountable for harm already caused. Thank you, signed Bridget Conroy. And Alex Colker, I see your two questions that you raised, and we'll make sure that the that the speakers are given those. And I'll read the last two comments we have. The first is by Angel Bradford from Sierra Club, and her comment reads, members of the Climate Task Force, my name is Angel Bradford. I'm a South Louisiana resident and volunteer lead of the Delta chapter of the Sierra Club. I fully reject carbon capture and sequestration and utilization and storage and whatever else we call these things. It's maddening to see mega projects coming to fruition when the science and public support for these projects are not present. CCS is a ruse, a joke, and a waste of time intended to recommit Louisiana to oil and gas. Those days are over, and we need to be real about the dangers of CCS and the fact that we have no future if we don't get serious about the climate crisis. CCS should not even be entertained by this body. It's time to reject the lies around technology that do not exist, and time to reject the oil and gas industry wholeheartedly. Signed, Angel Bradford. And Logan, I see your written comment, but will not read that since you already read it into the record. And then the last comment comes from Kim Goodell, and her comment reads, reference is made to that application by the state of Louisiana requesting that Louisiana be granted primacy. It was in the 2019 legislative session that a suite of bills were proposed to facilitate this untested yet to be fully developed newly emerging enterprise of carbon sequestration, more specifically HB 163 providing for carbon capture sequestration and the transfer of general liability to the state of Louisiana. And second, HB 510 and 615 voluntary audit bill, which was fully vetted and debated and tabled to be proposed again in the 2020 and 2021 legislative session. And three, HB 545 that provided for the re-injection of certain produced fracking fluids at the discretion of the operator, eliminating all government oversight, input, and approval. Following the 2019 legislative session, LDQ conducted a series of listening sessions for the voluntary audit policy. I submitted public comments at the same time and attached them here for the same period on Class 6 well primacy as well. And her comment reads, it's apparent that industry has failed to report water discharges. Some of these discharges, no doubt, are within the confines of areas requiring greater scrutiny under the SDWA. First are areas of aquifer recharge, our wellhead protection areas, and exception to aquifers. Failure to report will not only exacerbate cleanup efforts, it also conceals the actual threat to public health, depriving the public of their right to know. Failure to report also deprives the agency of critical information necessary for the protection and conservation of our water resources and our fragile ecosystem and wetlands, which are critical habitats for healthy wildlife and marine life. So what does DNR know about this discharges and toxic sites, reported or not, and their impact to all our EPA designated sole source aquifers, to our groundwater, to our surface water resources? Cumulative, how do these discharge impacts impact the sustainability of our aquifers? Can you identify all freshwater aquifers no longer fit for consumption and help the public put into perspective what the threat is to their health? And with that, that is Kim Goodell's comment on primacy Class 6 wells that she asked to be read into the record. With that, I'll pass back over to our chair.
May I ask, Alex Kolker had two questions and we didn't hear them. Could he present his questions or his comments? He's a member of the Science Advisory Group.
Sure, Alex, if you want to, or if you're able to come off mute, I think I just gave you that authority to do so.
He's at LoomCon down the bayou.
Alex, are you able to read your questions into the record?
Yes. Yeah. Hi. Are you able to hear me now?
Yes.
Yes. Great. Thank you. So I have two questions for the panelists. The first one, and particularly the first one, goes to Mr. Whitaker, and that is with respect to the subsurface impacts. I wonder if you could comment a little bit more depth on subsurface impacts and the potential for faulting or slips in the subsurface, and particularly in Louisiana, and additionally the potential for subsurface movements, in areas where there might have previously been oil drilling. And while you're making those, reflecting on that, keep in mind, the differences in geology between Louisiana and Illinois, and if that might impact any of your answers.
Thank you for those questions. And our discussion has concluded for the day, but we will, like we're doing for our last meeting, we are going to put together an FAQ and work with our panelists to help provide answers, because I know there were a lot of questions that were raised, not only in the public comment, but also in the chat. And so I want to try to provide as much information to the public as well as our task force members as possible. But thank you for your question. And with that, I will entertain a motion to adjourn.
So move.
Have a motion, have a second.
Second.
A second. All right. All in favor, say aye.
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 Opposed, nay. All right, meeting adjourned. Thank you all very much for your time and very thoughtful discussion. Take care. See you next week.
Thanks, everyone.